heat engine is a very important concept. Okay, nowadays we are using that automobile engines. It plays a major role for transportation. Okay, that too using the motorbikes and cars. There are engines which take that input as a petrol or diesel. Okay, and then this converting has a rotating the wheels by the engine. Okay, so most of the automobile engines have efficiency is not greater than 40%. Okay, so it takes the petrol is consumed for the energy. Okay, then it will deliver the work done by as a rotating the wheels. Okay, so that we have to understand about the concept of heat engine is very important. Heat engine means is a device. Okay, the device which takes the heat as input and converts this heat into a work. So heat is input, then output is called work. Okay, undergoing some cycle process are there. So here this heat engine means so hot reservoir, which means a source of the heat. Okay, hot reservoir or source of heat which supplies the heat into the engine. Okay, it is always maintained at a high temperature, say TH. Okay, so the amount of heat is called QH, temperature is called TH. The H indicates high temperature. Okay, then working substance, we are taking the working substance, maybe gas or water. Okay, which is easy able to convert that heat into the work. Okay, then third one is called cold reservoir. Okay, or sink is always maintained at a low temperature. Okay, it is gain the energy from that heat. Okay, clear? Hot reservoir maintained at high temperature. Heat engine is meaning of a working substance, maybe gas or liquid. Then cold reservoir means it's maintained at a low temperature. Sometimes it is called as a source, so hot reservoir. Cold reservoir is called as a sink. Okay, so what may be heat engine is a device which takes the heat from the hot reservoir and convert it as a work done. Okay, then using a cyclic processor there. Okay, I already told the heat engine is working during a cyclic process. Okay, after a cyclic process it returns to the same state. This means the heat engine returns to the same state of after it adjusts the heat to the sink. Okay, so the change in internal energy of the heat engine U is equal to 0. That U is called internal energy of the heat engine. Okay, so that we have to find the what is the efficiency of the heat engine. So efficiency means is a gain. Its symbol is eta. Its formula is output by input. Output by input is the meaning of efficiency of the heat engine. Its symbol is eta. Okay, which means efficiency we can define is a ratio of that work done is called output by heat absorbed as the input in one cycle process. Okay, so let the working substance absorb the heat, say QH. So eta is equal to rate work done by heat absorbed. Okay, so the amount of work done is called W, is symbol. By heat absorbed means it's a QH. Okay, okay, we know the water means what. So the input heat from that hot reservoir, it will separate as a work done plus exerted heat. Okay, so we will write as input. Input is equal to QH. Then output will be work done, say W. Okay, so the input it will be treating as a QH is equal to the work done plus heat exit is meaning of QL. Okay, so in this relation what is work done? W is equal to the plus QL became minus in the left side, so W equal to QH minus QL. Okay, so the applying here for this equation, so this equation became eta is equal to W by QH. What is W? QH, the amount of heat energy in the hot reservoir, minus QL, amount of heat energy in that cold reservoir. So H indicates high, L indicates low, by then heat absorbed is QH. Okay, so we can separate the QH in both the numerators, so that eta is equal to QH by QH minus of QL by QH. But the same cancel means it become 1 here, so that eta is equal to 1 minus QL by QH. So this is the formula for that efficiency of that heat engine. Okay, here the value of QL, QH and W are taken the positive. Okay, suppose the value of QL is less than QH, the amount of heat energy H is more now, so that efficiency will be less than 1, because value is minus. Okay, which implies heat absorbed is not completely converted into work. Okay, next thing, so we have to, here what I am saying, the heat absorbed is not completely converted into work. Okay, so heat absorbed is not completely converted into work. So we have to introduce another concept, that is the second law of the thermodynamics appears here. Okay, which means the fundamental restriction on the converting heat completely into work. So what the concept means, we can converting heat into work, and we converting work into heat also. So both are meaning of reversible process. Okay, so we can state that the heat engine statement of the second law of thermodynamics. Okay, and then it is also called as Kelvin's Planck statements. Kelvin's Planck statement. Okay, according to Kelvin's Planck statement, okay, see here we not completely converted into work done of the heat energy. Okay, so here the statement, it is impossible to construct a heat engine that operate in a cycle, okay, whose the other effect is converted to the heat completely into work, which means we cannot convert the heat into full amount of the work. Okay, something will be waste, will be there, loss will be there. Okay, so this implies that there is no heat engine we can construct in the universe can have the 100% efficiency. Okay, so efficiency is not constructed with the 100%. Something loss will be there. For example, we are using that lamps and fans, correct? So for a light we are using our home, they taking the current energy, only the 5% current energy used for the glowing the bulb. The amount of current it will be consumed by the bulb is taken only the 5% only. The remaining the 95% will be as a heat, the waste. The main purpose of bulb is glowing or producing light only. Okay, so that take the 5% of current as an input, the remaining 95% will be as a wasted. Okay, same here also, same like that. The what is amount of heat energy is consumed by the heat engine, okay, is not fully counted into the work done. So the efficiency is not 100% in always. Okay, that is a statement by the Kelvin's Planck constant. Okay.